We are going to start the session right now. So welcome everyone to webinar on Midas Engine Software Solution. My name is Nivedita Khole. I'm the Technical Support Engineer in Midas IT. In this webinar session, we are going to look at uh, the company introduction to Midas Engine, then support services. We'll have a conclusion and we'll display a special launch price, and we'll take up some question answer session at the end. If you have got any questions, you can write at the questions box right over here, and I shall be getting back to you at this end part of the session. Okay, so let's start with the company introduction. I'll be very quick because we had already discussed this last time in the yesterday's webinar. So Midas was established in the year 1989 by POSCO Group, and our software solutions are distributed in more than 120 countries. There are more than 540 number of employees, more than 18,000 number of clients, more than 40,000 number of users worldwide. Midas has its headquarters in South Korea, and all over the world there are 9 branches. One is in China, USA, India, Japan, UK, Russia, Singapore, Philippines, and the UAE. Midas has 2 main business areas: engineering consultancy and software developments. Their engineering consultancy goes on in bridges, civil, buildings, and plant structures, geotechnical as well as mechanical. Based on the requirements, practical requirements, these softwares have been developed to cater the requirements of bridge engineers, structural, geotechnical, and mechanical engineering. Since 2003, our softwares have been loved by many users, and they are increasing with years coming. Midas has 4 main family programs. One is in bridges, under which we have Midas Civil, which is an integrated solution system for bridges and general structures. There is Midas FEA, which is an advanced nonlinear and detailed analysis system. Other than that, in structures, we have Midas Engine software solution, which we are looking at today, which is available for performing analysis and design of buildings and general structures. Midas Drawing is an auto drafting and rebar detailing module. That means a design from Midas Engine can be imported in Midas Drawing for generating the detailed rebar drawings. Then there is a generation of bill of materials in the form of Excel sheets by Midas Drawing itself. Then Midas Design Plus is our structural component design and detailing tool. Next, in the geotechnical field, we have GTSNX, which is a 3D finite element based geotechnical solution. And there is a SoilWorks software solution, which is our 2D finite element and analytical geotechnical solution for practical design. In the mechanical field, we have Midas NFX and Midas FX Plus. NFX could be useful in the features like impact analysis and CFD analysis. A 3D CFD analysis can be performed in Midas NFX. Now we'll move ahead to the next part, which is Introduction to Midas Engine. Midas Engine is the next generation solution for building analysis and design. Midas Engine is actually a complete analysis, design, and drafting tool. So you need not have 3 different software solutions for the entire project. Use just one software solution, that is Midas Engine. You can actually start with architectural drawings for the modeling, perform analysis, design, generate reports, take out quantities, and finally generate structural drawings. So from drawing to drawing, you can get an all-in-one design system. The main features are integration, automation, optimization, and high-quality report generation. Let us look at the integration. In terms of integration, we are saying that modeling, loading, analysis, design, output, everything is integrated into one software solution. There is easy and fast CAD-based modeling method. We can have auto generation of specialized loads. There can be multiple analysis cases for a single model file. Multiple design cases can be applied in the single model file. Output generations are in the 3 types like Word file, Excel sheet, and DWG file format. Let's look at some automated functions in Midas Engine Software Solution. Let's start with the modeling functions. We have seen yesterday about this feature as well, that is the tracing feature, wherein you do not need to define the section properties of the columns. Just drag around the entire plan and you'll get all the section properties and thicknesses automatically detected by the program. You can also use the centerline plan or center lines to locate the beams at a particular story. You can even do easy modeling using coordinates or snapping tools. You can detect the entire floor plan for the slabs. Simply select the unrequired slabs and delete them. That's about how you can actually create your columns, beams, shear walls, and slabs very easily in Midas engine tracing. There are some editing tools as well available, like you can move very easily, copy, stretch or reduce, extend, trim. You can also have various shapes of openings very easily generated by simply sketching them. You can have irregular shaped bodies modeled very easily using our functions like sweep, revolution, or even a trim option. In Midas Engine, we have auto mesh feature, so you can actually have any shape of any size of meshing as required. All types of foundations can be modeled in Midas Engine software. You can have strip footings below walls, isolated footings, footings. You can also have basement walls and apply earth pressure easily to the basement walls. Then footing girders, as in you can assign soil spring supports to the footing girders like plinth beams and pedestals as well. You can also have pile supports modeled in Midas Engine. And that's about the automation in the modeling part. So let us start with Midas Engine software solution. We'll open Midas Engine and we'll look at how we can do the modeling of our steel structure in today's session. So I'm going to have a very fast solution over here for drawing the truss, and that's by importing the option. We have import DWG or DXF, wherein you can import a 3D truss or even a 2D truss. I'm going to import a 3D truss over here. Okay, this comes in fit. All right, and I'll click on OK. So we have a 3D truss modeled over here by simply importing from a DWG file. All right, now I'll simply convert this sketch, which I got imported from DXF file, into members. So for that, I can go to this body tab and use convert into member. I can select the lines which I want to convert into members. For example, this bottom chord, I can convert it into beam having section property of C15276 by like basically select the property. Now, these properties you can actually create by yourselves. There are some section properties predefined. Material properties are also predefined. So you can modify the predefined material and section properties. So here we're using American Standard. So you can select from here the grade of steel, and you can also edit the section properties. You can say modify and come to a location wherein you can draw any shape of your choice for section properties. So here I have this section property, and if I want, I can just simply select everything and delete. Then I can go for section template steel type, and here I can select AISC. 0.05, and we have got several types or several shapes available. So if I go for a channel section, then I have again the huge database of the types of different types of channel sections or C sections. So I can basically select from here and then say insert template. So here I have the template to be inserted, and then I can just say apply and close. So this in this way I can have my section properties modified, and this would be applicable for everything. And you can also add your own section properties. Okay, so that's one part. Next, I'll also go ahead and use some polygonal selection type. So that I can select my members, my line elements easily to convert them into members. So this is also selected. I can select the type of the property. So this is done, and then I can also have brace type of members generated. Let's say angle section. So I can actually select my I'll use again a pick selection. So I can just make a box and make the selection easily and click on apply. So this is how we can actually create the entire model. Okay, just let me check with the dimensions while importing if I've correctly done that. It's 8 meters, seems to be too big. That says 64 meters. Okay, let me just undo this import. Sorry. We have several importing functions as well available. Okay, this seems to be fine. No. I'll make it smaller. Okay, 14.4 meters. All right, so I'll go ahead and convert these bodies elements into members. So let me do that. I'll select everything at once to make it quick. Yeah, C section. Oh, sorry. 64 feet was fine. Sorry, I got confused with the feet and meters. I'll just start all over again. Sorry for that. Okay, so this is supposed to be 1 time itself. This is correct. Get it back to meters for no more confusion. Okay, so unit system can be modified at any point of time. I'll go ahead with the selection. And angle section for the braces. Okay, so this is how the color difference would be if we choose the correct type of members. Okay, so that's one thing. Now, in case, oh yeah, one more thing is that even these would be our trusses. So you can actually select these. These are converted into members, or these are lines itself. So you can actually convert them as well into braces. So you can select the brace like this and click on apply. Yeah, so this is done. Then we will go ahead to draw our column members below this, and it's easy. Just click on column over here. It's like CAD type of modeling itself. You can select the section property and can draw it by clicking. So I'll make it as F8 to make it straight, and I'll click over here. Okay, and further we can go ahead, copy this element or member into a direction. So you can even click by 2 points wherever you want. Then further, let's look at some more editing tools like I would like to divide this into parts. So I can split these members into parts by ratio or by points, by 2 points, or by distance as well. So there are different options available. So I'll go ahead with by ratio, and I'll have 1/3 division of this member. And I'll select this and again have 0.5 or half of it will be divided again. And further, I can go ahead create my beams. So for the beams, I'll select the section, let's say you see 305 by 305, and Just like we have in AutoCAD, we can snap on to the ends, to the nearest point, to the center, and so on. Okay, and further, I've got some truss members as well. So I'll go ahead using the brace type of member. Here we have got several types of analysis types of members like elements. So for brace type of design, we can have beam type of element as well, or compression only, tension only type of elements are also available, and truss type of element is also available. Okay, so we can choose, and we can choose a section property, and I'm going to create some truss members over here. Okay, I think my intersect command was not on from here. That's why it did not get intersected. No worries. We can still go ahead and use this intersect command, and we can select all of this and click on apply. Okay, I'll get back to my braces so that my center point will be located nicely. Right, so here it is. So you can just go on drawing easily. If any incorrect location is selected, you can press undo. There is right click command also to come out of the command line, and so on. So you can go ahead and copy these trusses into upper portions. So such options are also available. You can even do mirror and so on. So there are various options available here. I'll copy this on this floor as well. So we can do options like these, and then further we can go ahead and copy this entire part into other locations. So I'm going to do that same. I'll copy it at from here to here and also over here. Okay, then further I've got some floor levels, so working levels over here. So I'm going to create my beams at these locations, and I'll use these beams to copy at some more locations. So just by clicking on one point to other, as you can see, it's pretty easy. If I knew the distances, of course, I can directly provide the values of the distance to be copied. Okay, this is how we can create our steel members. And further, if we have got the slabs at these locations, you can actually use the option. Okay, I'll save this project. Okay, so you can say, click on the periphery elements, and you can see the slabs over here, and you can actually click on apply. So you've got your slabs also generated. You can also create your roofing elements at the top. If you want, you can. If you don't want, you can actually use your floor loads command to apply the loads on the beams. You can model the purlins if you want to. That's also an option available. So here I'm going to show the floor load command as well. For that, we'll move ahead to the loadings now. And in the loadings, we'll go with the self weight firstly. And then we will go ahead with certain more options. We have got point load, beam load, pressure load option, temperature can be applied to the structure, displacement, arbitrary loads. So these options we also saw yesterday, and we also tried to apply slab load onto the locations where there are slabs. So same thing can be done over here. We can apply the slab load type, live load and dead load at once. So I'll just make yes, being an industrial shed over here, let's assume that there is a higher floor finish and of maybe 3 kilonewton per meter square, and a live load of, let's say, 2.5 kilonewton per meter square. Of course, it will vary as per the requirements. And I'll apply the slab loading on the slabs. So I can simply do the selection in this way and apply. So slab loads have got applied. Now we can apply the floor loads. So we'll go to the floor load type and we will assign roof loading over here. So you can actually give a name like roof, and you can provide the loading information like the purlin, and you can also specify the weight of the purlin and the roofing. So let's say zero point 0.5, and some static load set or live load. If there is going to be any live load on the roof, then that also can be specified. Important part is to provide a negative sign. So likewise, you can specify over here the weight, and then start the loading. So here we have load command. We can go for the one-way type, and to include the um, purlins, we have got the option. Okay, just let me apply the floor load firstly, add the locations. So I'll select over here the roof, and I'll click on apply. So we can make over here as a one-way type, and we can add several unmodeled sub-beams as well over here. Yeah, sorry, load transfer, and we can add over here unmodeled sub-beams. So let's say there are some 5 purlins, and we can add their self weight. So if, yeah, I mean, in the floor load type, you can actually choose to provide that sulfate of purlin, or you can provide the sulfate of purlin over here also. So both options are available. If you provide it over there, then no need to provide the unit sulfate from here. Okay, so these are the options. You can actually go for a 90-degree angle or a 0-degree angle. So I'm going for 90-degree angle because this is how I want the purlins to apply the load on these top chords. Okay, the same thing I'm going to do for the other side. So I'll start from the smaller direction and then to the longer side, and I'll click on apply. Okay, so I've got both these areas on which I want the roof loading to be applied, and then I'll click on OK. So roof loading has got applied, and the purlin point loads are also considered on the stop chord beam members of the roof. So that's about the loading. I'm sorry, I think I missed out one modeling part, that is pedestals and isolated footing. So foundation is not modeled yet. So let me go back to the member and show you how we can easily do the modeling of pedestals and footing girders, and we have isolated footings as well. So we'll see all these three options. So when it comes to pedestals, you can specify what is the height of the pedestal. It's 1 meter, 1.5 meter, or anyhow, and what is the section size. So you can specify the section size of the pedestal, and all you have to do is simply select the columns below which the pedestals are to be created. So you can see here, these are the pedestals. I'll click on apply. So we have got our pedestals generated, and below the pedestals, we can go ahead and have the isolated footings in the same way. So here you can actually specify the thickness. I'll add a thickness of, okay, we'll change the grade of concrete. Okay, so thickness is 0.5, let's say. Click on OK. Let's change the material properties by simply modifying it. I'll use the American Standard A36 I'm using, for example, and American Standard for Concrete I'm using, let's say, grade C 3500. Okay, so this is what I've done right now, and I'm creating my isolated footings with a thickness of T500, and we have got different analysis methods for the isolated foundation as well. So we can have rigid method or FEA method. Both methods are applicable over here. Now I'm selecting the FEA method for now, and we will select these pedestals below which we want our isolated footings. So I need to specify over here what is the length and breadth. So this is how I specify, and then we can just click on apply. So we have got our pedestals, isolated footings, footing girders also we can have. Let me add a section property for the footing girder. I'm adding a simple section property of 300 by 300 for the for the footing girder, and this I'll just click on apply and close, and then go ahead to do the footing girder modeling. So here I can select the section property I just created, and we can just go ahead and select the two locations between which we want our footing girder. So it's like a combined footing you can have for this type of a member. So footing girder, or maybe if you use it for plinth beams, you can use it for plinth beams as well. So I'm using it for footing girder itself, and then I'll click. I mean, height starts from the bottom. So it starts from the bottom. If you want to move it up, you can. So there are options available. I'll keep the height as the bottom itself where our isolated footing is. So these are different options available. So I'll click on apply over here, and you can see this is how it will look like. Okay, so same thing can be applied at all these locations. So I'll be definitely providing this information one by one. We can also do it for the last and the first, and then we can see how we can, create the intersect command for dividing the beams into several parts. So I'll just select it like this, and then I'll intersect later on. Okay, and the same thing can be applied. Okay, I'll use my intersect command over here right now. So we have intersect, select all of this and apply. So we have successfully intersected our beams. So basically you can choose to create different types of members for the steel project. Okay, so after this is done, we will go ahead now to the boundary conditions for our footings, and we will provide the soil support. So here I'll be assigning a soil support information. Sorry. Yeah, soil support information. So we have got user-defined type of soil spring property definition, or you can have usage of Josephy balls. So you can use Josephy balls as well. And then you can use either linear elastic or compression only type. So those options are also available. If you're using Josephy balls, so you have over here the options to select the soil stress, provide the soil stress information, the allowable one. So I'll provide over here as, let's say, 200 kilonewton per meter square. And then I'll move ahead to the next part. Horizontal spring constant. So here we can see what will be the horizontal spring constant value, and finally the result will be displayed. So the final subgrade reaction would be 24,000 kilonewton per meter cube for the vertical, and for horizontal it will be 8000 kilonewton per meter cube as per the formula given over here and here. So I'll click on OK and close, and I'll select all my isolated footings, and I'll click on OK. So I've applied the soil spring supports to the foundation, and now we can move ahead to the next part, that is the analysis. Now before I move ahead with the analysis, let me generate some story data information so that we will get our drawings generated. So I'll have this automatic generation of story data, and I'll click on OK over here. So we have got the story data information. Automatically it has detected the basement or the foundation information. So from 0 level to minus 1.5 level, it is B1F and B2F likewise. Okay, so that's how we can understand. If we want the program to utilize the control data as the ground level, basically, as we want, let's say 0 is exactly the ground level, and then we can go ahead with the auto generation of story data and click on OK. So likewise it will again detect if at all you have not used as 0 your ground F level, then you can use any other level as your ground level. Okay, now there's several many story definitions that it has detected. So instead of all the definitions, we can choose a few because it has detected the locations for these points as well. The locations where these points are there. So it has detected those levels as well. So instead of having those points, I'll display the levels over here. Go back to story definition, and let's say till from 3F to between the 3F and roof, I don't want the levels, so I can select these levels and delete that information, the data information only. Okay, so now I have only this much information. Okay, we can also extract grid lines out of our structures. So we have auto grid generator wherein I can just simply click on extract, and we can find out what are the levels of the grid lines. This could be useful for the drawing generation as well. Okay, so this is done. Now I'll go ahead for the analysis. In the analysis settings, we have got again the option to choose the meshing and the solver. Combinations, we can choose the steel combination as per the American standard. So let me select the American standard over here for general, and steel and RC American standard would be used. And we can automatically generate the load combinations. So I'll add that for the steel as well as for the concrete. We can also have our own load combinations, not automatically, as we can manually create our own load combinations. And yeah, so that is it. Let's close this. Load combinations are done. Then further, we have the option to generate the analysis case for design for the superstructure and basement at once, or we can choose separately. And we can choose which boundary conditions we want to utilize, and then the loads that we want to use for the analysis purpose. After the analysis case is defined, we can go ahead for running the analysis. So I'll just run the analysis right now. Then we can move ahead for the design part. Okay, so before we move ahead for the design part, okay, there were locations where auto constraint was, there is a warning over here, one or more non-zero degrees of freedom were auto constrained. So some options were automatically constrained over here. So we need not worry about that because some elements which were not compatible with the other elements. For example, the 2D elements and the 1D element, if they are not compatible, then the program automatically constrains that degree of freedom. Okay, so that's the warning, and now we can move ahead for the design part. But before we go to the design, let me show about the results which we can get from here. So we can look at the displacement. Let me hide all the labels, grid lines, and datum tool as well. And we can hide the one way, two way. Okay, so we have our displacement that is displayed right over here. We can look at the maximum value. I'll change the unit system to mm. So maximum is 6.08 mm. Then further we can look at the reactions, but these would be at the nodes of our meshed isolated footings. Okay, let's look at the applied forces. Now, if you're going to be analyzing and designing the foundation separately, then you need the applied forces. So we can actually look at the applied forces at different nodes. I'll undeform this. Okay, so applied forces we can find. So you can see over here there are some applied forces you can actually take out as a table, and you can use it, or you can even use this create load by results. So it converts the analysis result value into loads, and then you can utilize it for performing the analysis and design separately of the foundation. Okay, so that's about applied forces. Then for truss members, we can see the truss axial force, torsional moment if there is any, then axial force basically for our truss members. We can see that over here. And further for beam forces and moments, again, the axial forces predominantly for the columns. And we can look at the bending moments as well. So we have this bending moment diagram for our column, for our beams and columns both. You can choose to view the results by plane or by story. So both options are available. So that's one part. Now I'll move back to the 3D and we'll see everything over here. That's about the beam forces and moments. And wherever there are plate elements like our isolated footings, our plate elements, because we use finite element analysis method for the isolated footings. So we can see the actual forces and so on. And after that, we can, I think, see over here the pressure value as well. So pressure Z value, we'll change the unit system to Newton mm, kilonewton meter. Yeah, so it's 88.46 is the maximum one for only the sulfate. But if we go for the combination, then we can see the results. It's 123.85 for the first load combination. So that's about the subgrade stress, I mean the pressure. And then further, we can look at the plate stresses, beam stresses, truss stresses, forces, beam forces, and so on. So that's what we saw in the form of image or display on the workspace. We can also get all these results in the form of tables. We also have got story irregularity tables available, like story drift, story displacement, story shear force, coefficient, and stability coefficient. There is stiffness irregularity checks and so on. So all these tables are available in Midas engine software. Uh, yeah, that would be it. Now we will move ahead to the design part. In the design part, we have design settings, wherein you can choose the settings separately for the steel. In the steel, we can see that the effective length factor and brace length factors, these can be program determined, or you can have user defined as well, wherein you need to specify your own effective length factors. Okay, then limiting slenderness ratio. So here we have the option to check or not check. So if it is considered, then what would be the compressive and tension slenderness ratio checks? Moment magnifiers, so the beta values, those can be program determined. Lateral load torsional buckling modification factor, web shear coefficient, and all these would be program determined. And check torsional strength. If you want to check for torsion, you can consider it. If not, you can say do not consider. Then general section strength, so you can choose it to be considered or not considered. Again, serviceability, deflection check will be there, fatigue check will be there. Seismic design, if you want to consider, then what type of frame it is. So it's a special moment frame, intermediate, ordinary, special truss moment frame, and so on. So there are several types as per American standard which you can consider for the seismicity. So if you want to check the fatigue, then you can check on consider, and you can specify what is the fatigue category, and number of fluctuations and so on. So all this information you can provide over here in case of steel. RC, yesterday we had already seen all this information. So I'll skip this part and we'll move ahead to the checking control. In the checking control, we can choose the demand capacity ratios, if it should be 1 or maybe less than 1 or more than 1 as per your choice. So that's for the steel members. And isolated footings, you can consider the compression reinforcement. You can also look over here for the footing girder. So footing girder also, there are some checkpoint options. You can select at what points the program shall check for the results and so on. So that's one part. Then there are some additional checkpoints as well, and we have got the criteria for strength check. Okay, so in the end, you can get the results in the form of colors as well. With these colors, you can identify which members are passing, failing, which are economical, uneconomical, likewise. Okay, so that's about how the design settings can be controlled. Combinations already created, load groups, sorry, not load groups, design groups. So design groups would be also automatically generated by the program. So let me show this. Okay, so basically we are taking care of the floor levels, and we are taking care of the section shapes, section sizes, and the lengths as well. So all these groups are created. You can also manually create your own group. Then further, there are some specialized member parameters wherein you can select which all members shall have certain effective length, unbraced length, and so on. So you can specify that manually. When it comes to RC structures, you can actually provide your own reinforcement arrangement. Let me initialize the structure and hide the labels. Okay, and further, we'll create a design case. We can have multiple design cases generated, and those will include our steel as well as RC. So at the same time, I can run both steel and RC. For RC, I can choose on rebar auto arrangement, and I can choose the different diameters of bars that it should select for the design. So I'm going to perform the design right now. So it has given an error. It says about the calculated rebar arrangement is less than minimum rebar ratio. So minimum rebar ratio that has been specified by the code is not met with over here. So we need, I mean, the reinforcement requirement is pretty less supposedly, and it is for the pedestal type of elements members. So you can actually choose to assign your own reinforcements to satisfy this minimum rebars criteria. Okay, so this is one part. We can actually see the the information about our pedestals from here. So this is our pedestal, and the status is okay. I mean, it is passing, it's no problem, but the rebar ratio, it's not satisfied yet. So we need to actually take care of that part. Maybe minimum required spacing and minimum required reinforcement shall be applied to the pedestals. You can do the modification over here, and you can go ahead with the design and check. Okay, so that's about the pedestals. Let's go ahead to the total status check, strength check, not the strength, the total status. Basically, it will show if any member is passing or failing in either strength or serviceability conditions. So yeah, we can see that there are some members which are need check. That means they are highly uneconomical. Then blue colors indicate that those members are economical within the specified demand capacity ratio limits. Then there are some critical isolated footings which are orange in color. There are some trusses which are also orange. Then we can see that there are some members which have failed. Some isolated footings and footing girders are also failed, and we can find out what is the reason for these failures. So one way is by going for the steel section and understanding from here why the certain members are failing. So as you can see that when it comes to our steel beams, there are members failing due to deflection, and the ratio is given right over here. By how much is the deflection ratio criteria failing? Okay, so we need to likewise modify the section property if required, or add some additional members in between, like truss or like brace it out so that the deflection would reduce. Then for the columns, it's all fine. For the braces, again, we have certain members which are passing, certain members which are failing. So there is a huge variety, but you can actually choose from here only the ones which have failed. So ng, you can just select likewise and you can find out what is the reason. So it's a combined reason, combined as in it's failing due to axial itself, because actual bending, it won't take bending, trusses won't take bending. So of course it's failing for the axial itself. So probably by changing the section size, it should work. Okay, so you can actually choose from here different section sizes, and these ones are those only which have been defined in the model file. Okay, so you can actually choose. Let's say I'm just making an example by selecting C section over here. So if you select another section property and run this redesign for checklist criteria, then you can see that the ratio has reduced a little bit, but it has not satisfied completely. So these are different ways in which you can, check for different section sizes. All right, so that is it. And after you're done the modification with your design, you can say update so that the reinforcement arrangement or the section sizes for the entire structure will get modified or updated. And then you can go ahead, run the analysis and design again. All right, so that's about the results. Yeah, one more last result that I would like to show is how we can get the report generated. So we have over here our uh, beams, and we have our truss members and column members and pedestal and isolated footing and also footing girder. So you can actually select all these. You can get a summary report. So it's a Word file report which would be generated by the program. This is for the isolated footing. And we will be able to see that the program has checked for the two-way capacity shear as well, shear capacity as well, and overturning capacity and sliding capacity. So checks with that. This is for our footing girder. So for footing girder, it has checked and it's failing in shear. The particular selected member was failing in shear. Okay, so that's one part. This is another one. Yeah, then further we have got, I think this was for the pedestal. Yes, this is for the pedestal. Pedestals are passing. Then we have got beam steel beam member, and we'll be able to get this information. Slenderness ratio check would be done, and shear capacity, deflection check, fatigue check is given. Okay, so that's about the beam. Then for the column, same thing is applicable. We can also get in detail information about the design that has been performed by the program. Okay, so let's look at that. So if I go for the design report, I'll just select one steel column over here and I'll click on OK to show how the report would look like. All right, so we can, sorry, I did not select detail. Let me select detail and select one column and OK. Yeah, so here is our detailed report generated, when we can see which load combination has been used and at what part it has been used. Then the ratio limit is checked, slenderness ratio, and then the combined ratio check. It'll check with the moments and it'll check with the axial and shear capacities. Then deflection check would also be provided. Okay, so that's about the detailed report generated by the program. Okay, so I'll go back to the presentation and we'll look at some more automations in the loading part. When it comes to loading, yesterday we had seen that wind loads can be automatically generated by the program for the building type of structure, and we also saw that there is enclosed structure option as well. For our structure, we can assign the windward, leeward, roof, and so on, all these uh, areas where the wind load is going to get applied with the auto calculation of the coefficients, pressure coefficients, internal pressure coefficients, external pressure coefficients, roof pressure coefficients, and so on. So that's one thing. Then seismic loads, lateral loads can be also automatically assigned, calculated by the selected code. And optimization, well, yesterday we saw that we can assign shape offsets to the program, and also consider the rigid zone of the location between the beam and column. Then further, there is a plate beam and wall column type of members available for defining drop slabs or beams located at each end of or either end of the walls. So those will be generated as beam elements and column elements respectively. The design codes available or applicable in Midas engine are as per European, American, European, British, and Korean standards. We have seen how American standard today could be applied. And now we are looking at the high quality report generation. So we saw that there is summary report that can be generated and detailed reports also generated by the program in the form of Word file. Good part is that you can see all the formulae as per the code and the subclause numbers as well. So if in case you have a doubt where the particular formula came from, so you got the subclause number which you can readily refer. Then further, we have got the high-tech report generation using a report maker. So this is a small video. I had played this yesterday as well, but for those who have joined newly, for them, let me tell you that we can provide the inputs and outputs as we want, completely under our control, into a location where the entire project report can be generated by simply one click. Okay, so you specify the information in this location and you can make a template out of it, as in you can use it for all your future projects. So you can actually control on the font size, the colors, and the information, or even the images that you would like to input. So everything is under control, under the user's control. And further, you can actually take this into a Word file. So that's how you'll get the entire project report generated. You can save that template and open it for your all future projects. So maybe once you spend some time in creating your template, you can use it in future for all your project reports. So that's about our report maker in Midas engine. Now I would like to also show you how drawings can be generated in Midas engine software solution. So I'll just go to the save, firstly settings. Yeah, first of all, I'll go for the settings, and here we have the foundation plan. We can see this foundation plan right over here, and we can see over here, this is our drawing set 1. You can have several drawing sets as required. Okay, and you can click over here on OK and save this information, and then we can go ahead to generate the drawings. So Midas drawing will be along with Midas engine software solution, and the design results from Midas engine will be imported in Midas drawing directly right now, and then we will see how the drawings can be created. So first of all, let's look at the structural design overview. So here the program is simply going to specify which codes have been used for the material, for the design purpose, and what is the name of the project, and so on. This is similar to AutoCAD, so you can actually use all the commands of AutoCAD. And now let's look at some more information. You can also get the structural plans created. So there is a column layout that can be generated from the program. So right now you can see over here that the program is collecting all the information from the Midas engine file. and finally it will easily generate all the drawings one by one. As in when we select, we don't need to wait for this time which is required right now for collecting all the drawings. Midas drawing actually is also capable of creating the section structural plans and structural sections as well. So let's see all that. So here I'm placing the column layout. So this is the column layout. You can see the column size and you can see the pedestal size as well. So this information is provided over here, and we can see the column list, what is the size and what shape, and then the pedestal size and material used for it. Okay, then further, the structural plans, floor plans, so you can choose the different floor plans. At the bottom, there will be a line which indicates how much time it will take for creating a particular drawing. So this is one floor plan wherein you can see this is a slab and this is the section for the beams right over here. One is G1. The group names will be specified in the structure plan and the section sizes will be specified in the table format. That's how the section looks like. The plan looks like. We can also generate the structural sections. So I'll create section 1 over here and I'll make a section right over here through this, and I'll specify its direction. So here we can see what are the sizes of our beams. Okay, so the place where I cut, it is showing only that much part. So if I go ahead and make another section, I provide a name basically to the section, and I'm creating a section over here which goes through this. So basically we can create several sections in this way, and we can also get the general rebar generations for our beams. So this would be a footing girder. So for footing girder as well, we can get the bar bending schedule and the reinforcement arrangement, the stirrup arrangement, all that information. So this is the bar bending schedule, the location of our footing girder, the reinforcement arrangement also for our footing girder. Let's look at more rebar arrangements. So yeah, that's it. Beams itself. We'll move ahead to the next part, that is our generate member list. So in the generate member list, we will get the information for pedestals and isolated footings and the list of slabs as well. Okay, so I place it over here. So this is for our isolated footing. We'll get a typical drawing over here, and we'll be able to see the information of our reinforcement arrangement for the top and bottom. We can have 3 layers. So yeah, up to 3 layers, we can have the reinforcement applied to the isolated footing. Okay, then we have information for our pedestal. So only one type of pedestal is there, one group only is there. So for that, what is the reinforcement arrangement and the main reinforcements, number of main reinforcements and so on. Then this is about the slab list. So you can get typical types of drawings for the slab, and we'll be able to see the type over here. Let me check if, yeah, we can get the slab reinforcement details over here as well. So we have got slabs on the 2F level. So on the 2F level, we have the slab reinforcement, and this is how the slab reinforcement would look like. This is the indication of the reinforcement for the slabs. Okay, and for the steel as well, we can get the result in the form of tables. So we have got the name of our member and the size of the member, material property used for it. So that's about a list. Okay, that's it. And lastly, we can also generate bill of material for our RC as well as steel members. So I'll just click on OK, and there will be an Excel sheet which will generate the bill of material for our entire structure. It will include the reinforcements information. It will include the weight of the, sorry, yeah, that would include the weight of the rebars and the volume of concrete, and also for the weight of the steel and the painting area. So all that information, we can get it in the form of Excel sheet itself. At the bottom, you can see it's right now on 36%. So we'll just wait for it to generate. And by the time it's getting generated, let me take you back to the presentation. Okay, so we saw that Midas engine is also capable of generating structural plans, elevations, and uh, drawings. Now let's talk about the Midas support services. If you would like to learn Midas engine software solution, you can go onto our website, and there are several tutorials available for RC as well as for steel structures. And finally, we'll come to the conclusion wherein you can actually have a one-stop solution for your roof, superstructure, and foundation. We can perform analysis, design drawings, and also generate report for all these members in one software solution itself. We can have several types of modeling features as required for your project. And you can also see that there are several applications for Midas engine, not just RC, not just steel, but general types of sections. When you can have the steel and RC together, modeling becomes easy, and therefore you can see stadiums and shopping complexes and the airport terminal structures with irregular shaped roofs, railway substation structures. These are some RC structural applications, and steel structural applications. There are RC buildings, sorry, steel buildings. Today we saw the steel warehouse, and stadium structures also are applicable. And finally, elevated water tanks and transmission towers can also be analyzed and designed. So that's one thing. Then we also saw that isolated footings and footing girder pedestals can be modeled in Midas engine, can be designed as well, and drawings and bill of material can also be generated. I think the bill of material must be generated. Yeah, it is generated. So this is our bill of material. For steel, we can see that the section information is given for the different beams, and we can see the quantity, meter, length in meters, unit weight in ton, and we can see the perimeter as well. So perimeter of our section is provided, and outer surface area is also provided, which could be used for painting. And then we have two types of bill of material for steel. This is one with the type information, and then there is another information based on the type as well as on other information. And then we have got RC members for slabs separately. And for the basement, we have got footing girder information. So you get the concrete volume in meter cube, rebar in ton, formwork area as well. So it's for footing girder, pedestal, and footings. That's it regarding Midas drawing bill of material generation. Okay, so we saw that everything is possible for all types of members. And yesterday also we talked about how we can perform the analysis and design for one-way, two-way slabs. Yesterday we saw the meshed type of a slab analysis and design, and today we saw how we can get the one-way or two-way type of slab analyzed and designed. Then ribbed or baffled slabs can also be analyzed and designed. I can share a video on the same. Flat slab analysis and design is also applicable with drop panels. Okay, then further we also saw that detailed design calculation report is generated in the form of Word file, and design check summary is also generated by the program for ready output information. Then customized submission report is there that can prove to be very helpful for all your future projects. Then here we have drawing generation and bill of materials in the form of DWG file and Excel file. Okay, so I hope you enjoyed the information that has been provided. Now let's come to the launch price. So Midas has a special launch offer for engineers of Middle East region, wherein you can enjoy all the benefits of the full version of Midas engine. So whatever was shown, you'll get. Definitely, it will also include the software training upgrades. As the software is new, it's getting upgraded every year pretty fast, and more features are getting launched in Midas Engine software solution. So right now it's like architectural drawings to structural drawings, including modeling, analysis, design reports, and quantity takeoffs. All of this you can get it at a mere price of 1500. The original price was 3000 per year. This is an annual subscription offer actually. So the original price was 3000, but now the launch price is directly 50% discounted. So you can take advantage of that. If you also go for two, you'll get two more licenses. So get four licenses at price of just two. And along with that, you'll get Midas iCAD license subscription free on this purchase. Midas iCAD is just like AutoCAD 2D. All the commands are applicable same way. So your drafting can be done for free in this way. I mean, you'll get a free drafting tool with the 2+2 offer. And yeah, this is applicable until 15th May 2020. Let me again emphasize that trainings and technical support will be provided free of cost along with this purchase. All right, thank you everyone for attending. We can have a question answer session right now. So let me open my question answers. Okay, one question is regarding steel connections. Is it possible to perform steel connection design here? Midas engine is not yet capable of providing steel connection design, but we have Midas Design Plus software solution that has the connection, bolt connection design available, and base plate design is also available in Midas Design Plus. So if you want, you can also add on with Midas Engine software solution, the Midas Design Plus software with Midas Engine. Okay, so you can definitely say likewise or tell us your requirement, and we can provide you the solution for that. Then yeah, same thing is applicable for base plate, so that is available. Next question is about deck slab for steel structure. So steel deck slab is not applicable. You can get the analysis result for steel deck, but if it is RC, then you'll get the design as we have already seen. Another question is about footing girder connected. Is the footing girder connected to the pedestal or as per our choice? So yes, it is our choice. If you want to connect it to the pedestal, you can connect it to the pedestal, or you can directly connect it to the footings or to the columns. I mean, your choice. So that's definitely your choice of how you would like to model your footing girder. Then Wind loads, yeah, wind loads can be applied in on our structure, on our steel shed right now, which we had. Another question is, can we design any kind of truss in Midas? Sorry, can you please elaborate on this? Any kind of truss, as in if it's a beam type of a truss or something like that? And if that is so, yes, all the different element types can be designed as truss in Midas engine. Important part is you have to select the correct member type. This session is recorded, so definitely we'll share this information or this recording with you. Purlins. Now the question is about what kind of purlin we can use. So yes, you can use purlins over here of any shape as desired. You can sketch your own shape. You can even import the CAD file of the shape of the purlins and create your own section property and assign it. But it will be only for the analysis purpose. It will not get designed. So design of purlins is not available in Midas engine. Probably you can use Design Plus software. We have our component design software solution, that is Design Plus, which can be utilized for the Purlin design. Even the crane girder design is applicable. Now the question is about composite section definition. Midas engine does not support composite sections. Another question, if Russian section is available or not. Sorry, I'm not sure if any of these is a Russian section. So let me go to the define 1D section. If any of these is a Russian code, then it is applicable. If you're into user defined, you can get for user itself. So you can actually specify the user defined cross angle, or you can just sketch, like you can sketch your section shape. Or if at all, let's say for example, there is one kind of section shape right over here, and if you're not using this information, then you can still do the modification from here directly. So this modification can be provided, for example, making it 300 likewise, and changing the sizes of any location. So this information can be modified and so on, and then you can save it and run the analysis. Yes, Midas Engine has connection with BIM tools like Tekla, and like importing from MGT. MGT as in you can convert your Revit or Tekla files into Midas Gen text file and get it imported over here. You can also have export. So export to Tekla is available. You can export to MGT file as well. We have connection with our geotechnical software solution as well. So you can actually have the entire steel structure or RC structure imported in Midas GTS NX, which is a geotechnical software solution for performing soil structure interaction. Plastic analysis and composite sections is not available in Midas engine. Yeah, can you design according to wind load? Yes, we can design according to the wind load as well. We just have to include the wind loads in the analysis and the design. and the load combinations. The design will, of course, take the most critical load combination. So definitely we need to have the analysis done along with the wind loads, and the combinations should also include the wind loads. Yes, bracings can be designed. Connection design is not available in Engine. We have it available in Midas Design Plus. Can design brace for tension force only? Yes, you can actually have the brace type of members as tension only type of truss elements. So that option is also available. Let me show you member brace. In the brace there is brace tension only. So if you use brace tension only, then the element will behave, will only take the tension force, and then the design will be based on this force only. All right, that is it regarding Midas engine steel structures. There are some more questions. I would like to answer them by email. All right, thank you everyone for attending this session, and have a great day. Bye bye and stay safe.